Hi, today I'm gonna talk about reviewing the fundamental of semiconductor devices. First of all, we have to know the concept of the molecule structures. In molecules, the electrons have their own energy level. It means no electrons can have the same energy state in quantum mechanics. So they have their own energy levels, which is quantized. But when the molecules are combine get together, so the space between them are too small, the electrons can have their own energy level because the molecules next to it have the same energy level electrons. So in this case, the energy level are divided in several energies. So some cases are exist like in the aspects of energy, the energy level are separated in very detailed energies, so it looks like a band. But it also means there also are exists some energies which is not exist the energy level. So this area is looked like a gap energy band. So we can call it as a energy band, a forbidden band, which is called energy band gap. Uh, In the case of silicon, which is most often used for semiconductor, have the 1.12 electron volt energy band. Mm, uh, and the silicon have the 4 electrons in the most outer energy level, energy orbital. So we can dope family 3 or family 5 materials on it. When we dope family 3 materials on silicon, we can call it acceptor, and when we adopt family 5 materials on silicon, we can call it a donor. And we combine these two kind of semiconductors, which is p-type semiconductor and n-type semiconductor. We can call it p-n junction and easily p-n diode. In p-n diode, because of the energy levels difference, the electrons on p-type semiconductor, n-type semiconductors it's hard to move to n-type semiconductor, but we apply on it. We can apply a bias on it. We can move the electrons of each other side. In this similar process, we can make a MOSFET and MOSFET. For example, in MOSFET, we put a substrate, for example, p-type substrate, and on it we put a silicon dioxide for insulator and put a metal for gate and dope n-type on substrate in two sides. One side is called source and the other side is called drain. When you apply bias on gate, it controls the making the channel between the source and drain. And in the situation like the source is grounded, we apply a bias on drain. We can control the current between the source and drain, which flows through the channel. Like this, we can use the semiconductor as a transistor. Nowadays, the important thing of the transistor is scaling down the chip, because if we put many chips in one wafer, it is directly lead to the yield. But there are some problems on it. because of short channel effect, which is occurs between the source and drain or the other capacitance or the punch through like this, we have to overcome these problems to scaling down the chip. But the most important thing is sustain the stable current or some process on it. Thank you. Today I finished my reviewing of fundamentals of semiconductor devices, and next week maybe I will talk about the lithography. Thank you.